This lab is on the thermodynamics of the thermal unfolding of chymotrypsinogen. So to begin this experiment, I'm at the home menu of the Cary UV-Vis 3500 that we have in the instrument room. And the first thing I'm going to do is to choose a thermal scan, which I've just clicked, which brings me into this screen. But now what I have to do is choose the wavelength. So the next thing I'm going to do is go over to this next menu item, and it says 260. But I want to measure the absorbance as a function of temperature at 293 nanometers. So I put that in, and then I delete the 260. I could put several wavelengths in here, but I don't want to. I just want to do the 293. So now at the temperature collection menu over here, I choose to start at 20 degrees C. Okay, and that's what I've put in. Now the next thing I have to do is put in the number of stages. Now these different stages represent 3 different parts of the experiment where I will be changing the temperature differently. Okay, in stage 1 and stage 3, that will be well before and well after the transition temperature, and I will change the temperature, more slowly, and I will collect absorbance data only every 3 nanometers. Oh, sorry, every 3 degrees C instead of every 1 degree C as given here. So I'm going to change this 1 to a 3, so it'll collect and I'll measure the absorbance every 3 degrees. Okay, and then what I'm going to do is I'm going to set the rate. Okay, so I wanted to measure, I wanted to change the temperature by 1 degree C per minute, as I've changed there, and this will happen between the original temperature of 20 and 47 degrees, which I've just put in, or I put in before. Then the second stage is when the transition actually occurs somewhere along here. So I would like to collect data every 1 degree C, but I would like the rate to be half a degree C per minute because I don't want to miss anything. I want this to happen nice and slow so that I can get good data for the absorbance as it goes through this transition. And that will go from 47 to 60 degrees C. So again, in the third stage now, I'm going to go back to the 1 degree C per minute. I'm going to collect data from 60 to 81 degrees, okay? And then I'm going to go and change also the data interval back to 1 as well. Here I'm going to next tell the instrument which cells will be used, which sample holders will be used, and which will be unused. So I'm only going to have a sample and a reference, so I just make all the other ones blank. And the next thing I'm going to do is go down to the next menu item. Just wait a little for the click. Okay, go down to this menu item, and I'm going to tell the instrument that I only have 1 sample. But I wanted to zero it in this. So what I'm basically going to do is measure the absorbance of the sample relative to a reference cell. That's what choosing 0 here does. As soon as the instrument comes up to temperature, I can click the little arrow on top, which will start the scan. And then, it will basically be automatic. Okay, so once the thing starts, it'll change the temperature in the intervals that I have specified for the 3 stages. And at the end, I'll get a very nice, display of what the absorbance is at 293 nanometers as I go from 20 degrees C to 81 degrees C. Okay, so this is kind of what it looks like. You can see at the beginning, in the first stage, the temperature changes much less rapidly than in the middle, which is near the transition, or during the transition, changes much more rapidly, and then it starts to change much less rapidly for the last section of the data collection. So that's basically it. If you were doing this experiment in lab, you very well might have gone home and come back in the morning to see what your data look like. So I will give you those absorbances as a function of temperature to enable you to do the write-up of this chymotrypsinogen lab.